Let's enjoy together integration by substitution, example 2F, we will call it. All right, now, pulled a fast one on you here just to make sure you're paying attention. You'll notice this new integral here does not have limits of integration. All right, it's an indefinite integral again. These behave in different ways, and so this was my attempt at reminding you of that. The other thing I'll point out is that we brought that upstairs, which created a negative exponent, and also because of the radical, it would have a fractional exponent. We talked about that so much, so that would be the negative 1/3 power. Radical, fractional exponent, and negative because we brought it upstairs. Now look, if it's already upstairs to begin with, like this one, it would not have a negative exponent. So remember, if you're pulling it upstairs, it'll generate a negative exponent. But look, this is back actually to Roman numeral number 1. This is an indefinite integral because we do not have limits of integration. And I hope you would concur that the quantity that has the power on it should be what we would call u. Let's also talk about the fact that we cannot distribute the 7x into the parentheses because the exponent takes precedence over the multiplication. So that original integral is landlocked, so to speak. That's why we're doing substitution. All right, so this becomes u to the negative 1/3 power. Cool, all right, simpler. X, you're too complicated for me. I'm going to run off to a simpler u over there. Build a dx, every time, build dx. Differentiate both sides of your original substitution with respect to x. So that'll be du dx, this will be 10x, boom, all right. Clear the fraction. I hope you're seeing the pattern. Once we make that original substitution, we're always doing this, and then we're just kind of stepping back and seeing what happens. So you notice the du turns out to be 10x dx. And you look at that and go, okay, I got the dx that I wanted. You always will get the dx. But what else fell in our lap? 10x. And you inspect the original and you go, boy, that's pretty close. It's a 10x, but the original one was a 7x. All we got to do is change the 10 into a 7. And we'll have 7x here, won't we? Wow, so that other expression in this case is kind of falling in our lap, so to speak. So now the question becomes, how do you change that 10x into the 7x? And my logic would be to cancel the 10, in other words, introduce a fraction with a 10 on the bottom, because that's a 10 over 1. Over 1! So cancel the 10, replace it with a 7. So if we multiply both sides of this by 7/10, algebra, right? And it's creative in my opinion. That's why people love this so much. You get to use your algebra creativity, don't you? So 7/10 du equals 10's cancel. That becomes 7x dx. And doesn't this now match the original? So the 7x in dx becomes 7/10 times du. Wow. Okay. So I put the 7/10 in front. It's a multiplier. It's a numerical multiplier. And so 7/10 du, that takes the place of the 7x and the dx in the original. Just make sure everything in the original gets replaced. Substituted. So this new integral is a single term with a power on it. It is much simpler than the one over there. That's the whole point in doing substitution. So 7/10. Okay, now we integrate that. We find its antiderivative. Add 1 to the power. So negative 1/3 plus 1 is positive 2/3. And then keep in mind, instead of putting that over 2/3, invert multiply. So division by 2/3 is the same thing as multiplication by 3/2. Oh, hey, wait a minute. This one didn't have limits of integration that we substituted. This would be the one where we need to remember to add the constant there. Waitress! I hope you read the joke. If you read the joke, you get the reference. Waitress plus c, all right? And then, clean it up a little bit. Let's multiply that. That'd be 21, 7 times 3. 10 times 2, 20. 21 over 20, u to the 2/3 plus c. Now, okay, it's been a while since we've seen examples of this type. we always need to remember that when it's an indefinite integral, we substitute back, because we have to remember that our answer is going to be, if you integrate a function involving x, your answer is going to be a function involving x, if it's an indefinite integral. So see, when you're indefinite about things, you're like, oh, x, you're too complicated. I'm going to run off with you, all right? Yeah. But then you're like, oh, you know, I'm not really very definite about things. I guess I'll go back to my x. So in this case, you substitute back, so you're just not very definite. You just, the u, go back to your x, you're just not sure about things. So this would substitute back as 21 over 20, and then the expression that took the place of u, clear back here, 2/3 power plus c. In other words, change the u back to the x expression that it took the place of. Again, indefinite. Run off with u, integrate, go back to your x. Okay? There's the answer to this question. Woo! That will be the end of integration by substitution. That would correspond to assignment 27. Good luck with it. You got this.